Great. So yeah, welcome everyone to today's webinar. And yeah, we're excited to talk to you about getting to grips with Git and GitHub. So like I said, I'm Amelia, I'm with Joe today, and we're just going to talk to you a bit about things that we've learnt and use with Git and GitHub over the last few years. So just to start with a bit about who we are and how we use Git and GitHub. So I'm a postdoc at the University of Edinburgh, and I use epidemiological and statistical methods for mental health research. So during my PhD and during my postdoc, I do data analysis. So I use R and Python mostly to write scripts. So I use Git to help with version control of those scripts, and I use GitHub just to put those scripts so that my colleagues and other people can see them. I've also been learning about Nextflow, which is for making reproducible pipelines, and I've been using GitHub to work with a colleague collaboratively. So doing things like using branches and pull requests and code reviews. So those are all topics we're going to share with you today. And I also enjoy using things like GitHub Actions, which is really useful for automating things like testing, so doing unit tests, and also for deploying your websites to GitHub Pages, which is a free way of hosting a website. So we'll touch on those topics as well. So that's a little bit of what I use Git and GitHub for, and Joe's going to introduce himself now as well.
Excellent, thanks, Amelia. So yeah, I'm Joe. I'm a data scientist. I originally worked in academia a few years ago at the University of Glasgow, and there I was interested in pathogen transmission and using genomics and combining that with population information to understand, in my case, how bacteria are transmitted between cattle and livestock and wildlife populations. And that was my sort of introduction to coding and data. And alongside that, using version control to sort of to keep track of my own code bases and also share those code bases with colleagues. But a lot of that work was working independently. So it was only as I sort of progressed in my career that I started to use Git and GitHub more collaboratively. And that started when I moved to University College Dublin, continuing to work in academia in a similar area, but starting to develop tools that other people can use. So really starting to leverage version control a wee bit more. And then my sort of real acceleration when it comes to using Git and GitHub was when I joined the Office for National Statistics in their data science campus, and I worked in international development there. And my role was around sort of doing and building data science capability all around the world. And the reason I say accelerated is because there I sort of joined an organization of data scientists, and we used Git and GitHub to work collaboratively on all sorts of different code bases. So that was a real learning opportunity for me. And then since leaving the Office for National Statistics, I've come back to the University of Glasgow and I work within university services. And my role here is just thinking about what opportunities there are for data science in the way that we run the university and how we interact with students and staff. And it's interesting, I've sort of moved into an organization where using version control is relatively new. So there's lots of opportunities for me to build capability across the organization and also chat about and discuss the value of version control and why it's important as we sort of introduce data science methods across our processes. So yeah, that's me. So we'll get started with just a quick question, and feel free to chuck comments in the chat, but just to get an idea of how many of us have used Git and GitHub before, these version controls or similar version controls like GitLab and Azure DevOps and others. So yeah, has anybody used these tools before? Excellent. So I see a few comments coming in. And it's a good mix as well. So we've got people that are new to it, and some of us have got a a bit of experience. So that's great, and often the case. So yeah, there's always a blend of people with exposure to these tools, and hopefully there's content within this presentation that Amelia and I will go through that will touch on different aspects. So for people that are quite experienced using Git and GitHub or tools like GitHub, there'll be aspects hopefully that are useful to you. And for those of us that are maybe new to these tools, we'll touch on some of the fundamentals and why they're valuable as we go on. So there's some useful content in there for all of us. And it's great to see that we've got this mixture of people with different experiences. So firstly, just going to chat a little bit about version control and what we mean by that. And essentially, it's just keeping track of different versions of our files. And we'll all be really familiar with that. We use tools like OneDrive and Google Drive and Dropbox, and all these tools are essentially just keeping track of how our files are changing. And this image is kind of just to illustrate what it often looks like in the creation of Word documents. We'll all be checking out Word documents for all sorts of different things. And we sometimes use the names of those documents to do a bit of version control, basically manual version control. And you can see here that can work well in many cases, but often it can get quite messy, and we'll end up with lots of different files, and it's not immediately obvious to us or others which of those files we want to use. But version control is just as simple as that. It's just keeping track of how files are changing. And this is where Git comes in. So Git is a tool like SharePoint and Google Drive and Dropbox that enables us to version control files. And it's a little bit different to those other tools. And the way we sort of describe it is that essentially it's just taking snapshots of files in a folder. And the reason why it's different is one, because it's working at a folder level. So it's looking at everything within a particular folder, and that might be everything that you have for a particular project. So all the code that you have related to a particular piece of analysis, for example. And it's also taking snapshots. So this is where it's different to tools like SharePoint and Google Drive, which are just working in the background, helpfully keeping track of how our files are changing. Git is asking for a little bit more action from our side. So we're going to tell Git when we want to take a snapshot of the files. And the reason why that's particularly valuable from a coding perspective is because while our files are changing, we can annotate those changes. We can annotate those snapshots to tell ourselves and other users of our code base what the changes we've made at a particular time are doing. And we'll touch on that in a little bit more detail. But yeah, so Git is a tool, a version control like many of the other tools we're familiar with, that takes snapshots of files in a folder. So just a simple example here is what it might look like for this presentation. So Amelia and I have used a tool called Quarto to build this presentation, which is just an open source reporting tool that's very flexible, and we can use it across a range of languages. So we're using it here just to make this simple presentation. And on the left-hand side of this slide, we're just seeing what we might have done were we not using Git to version control our presentation. And we might end up with lots of different files. We've dated those files and we've annotated those files with different notes that sort of tell us where we're at. But the problem that we see, one is that these dates were from a long time ago. So it's a bit strange that we were doing this presentation 2 years ago, but also it's not immediately obvious which of these files is the final one that we should be using for the presentation today. And on the right-hand side is what Amelia and I actually have. So we've used version control for this presentation, and it means that we've just got one file. So we know we can use this file to generate the final presentation that we're looking at today. But the left-hand side also has a bit of history around how the file has changed, and we haven't lost that when we've used a tool like Git to do our version control. And in fact, we have it in a much richer form. So we've got a really clear history of how the files changed, when the files changed, and also who's making those changes and why they're making those changes. And we can access that history using tools like GitHub. And here's just an example on the left-hand side of Amelia and I working away on this presentation. So we've used Git and we've used it in combination with GitHub. And on GitHub, we can go back and look at the history of how our presentation is changing. And you can see the key things that's being recorded are what changes are made. So within GitHub, you can go down to the line level within a file and look at how the file is changing. We've recorded who's made those changes. So it's either Amelia or myself. And we've recorded when they've made those changes. And we've also got this little note on as well as exactly showing how the files have changed. We can annotate that with little notes describing the work that we were doing. So we end up with a really rich record of how things change. So before we progress further, there's some really key concepts to get into your head as we talk about Git and using Git and other version control for our version control. So the first concept is a repository. So this is essentially just a folder that we have all the files related to a particular analysis or a particular tool that we're working on, but it's called a repository in the context of Git. And that's a folder which essentially Git is watching. So it will keep track of how things change within that with your help. Then we've got commit. And a commit is essentially another way of saying saving. So it's our opportunity to commit changes, to save the changes that we're making to the files within our folder. And then we have branches, and we'll chat a little bit more about those in a wee minute. But that essentially allows us to have different working versions of our code base. And that means that if you've got multiple people working on the code base on different tasks, then instead of everybody working on the same set of files and sort of creating conflicts, you can use branches to divide the work up and divide those tasks. So that becomes a really crucial tool to enable collaboration. And another key concept is just collaboration. How is Git and tools like GitHub and GitLab and Azure DevOps and so on, how are they enabling us to collaborate? And we'll chat a little bit more about that in a wee minute. But it's amazing how simple tools like this, just keeping track of how files are changing alongside branches and other tools like GitHub, enable us to really work effectively on our code bases. And as we think about saving and committing our changes, there's also two other key concepts. So it's pushing and pulling, and these are sort of critical to collaboratively working on a code base, because we imagine that I might make some changes. I will then commit those changes and push them up onto my repository in GitHub. And then Amelia might want to have access to those changes and also make changes of their own. So Amelia would pull those changes down to have them on their computer to work away on. And lastly, before we progress a little bit more into the detail of these, a key thing to think about is what's the difference between Git and GitHub or GitLab or Azure DevOps. There's lots of different tools out there, but what's the difference between Git and GitHub? So Git is the version control tool. So it is the one that is keeping track of how things are changing, and it's keeping track of how things are changing on your system, so on your laptop or computer or however you're working on your code bases. And GitHub is a platform that allows us to share our code bases. So whether that's sharing internally within our team or sharing externally to all sorts of people all around the world, GitHub is the tool that enables us to do that. And it does that by being cloud-based. So we can upload our repositories and we can work together on them. And by using Git and GitHub together, we can enable that effective collaboration. So before we move on, we're going to talk, Amelia's going to talk a little bit more about branches. But before we do that, just a question. How many of us that have used Git and GitHub or other similar version control tools have worked collaboratively on a code base before?
Okay, so just talking about collaboration and working with others then. So using Git branches is a really useful way of working collaboratively with others, like Joe mentioned. And so a branch is essentially a new or a separate version of the main repository. And when you're working on Git, typically you have a branch, you have your main branch, and this is a series of commits where you've in time on your main branch, but you want your main branch to be clean and working code. So how do we develop our code if we need it to be always working and clean on this main branch? So one way to get around that is to use these branches, these side branches with Git. So to make a side branch like this, we'd use the Git branch and Git checkout commands. And here we're just making a side branch called initial content. So here I'm branching off the main one to create this branch to then develop the initial content for this presentation. And here, this is just a copy of what was actually in your repository at this point in the main branch, but we've just made a copy of it here. And now we can kind of work with that copy and make our changes to that code. So we would do git add and git commit as we make changes on this side branch, kind of developing our code until we're at a point where we're happy with it and it's clean and working and able to merge back into the main branch here. And so this is really useful when you're working with other people. So say I was working on this branch, maybe Joe came along and made a branch to make the Git glossary here. And then you can also have branches coming off other branches. So say I made a branch to work on a Git flow diagram here, which was coming off this side branch. And because we're working on these separate branches, you don't have to worry about overwriting what someone else is doing because you're working separately. And then when it comes to kind of resolving any conflicts in the scripts or the code or whatever it is that you're working on, that's when you can resolve those when you merge them back in together. So say you've been working on one file together and in different branches you have different edits to the same point. When you merge them back in, that's when you can kind of resolve those and decide which version you want to keep. And then we can merge those back into the main branch when we're happy with that content. So I would say that Git branches was probably one of the more confusing topics that I learnt when I was learning Git, and that really the best way to learn it is just to have a go. So we share a resource at the end of this presentation where you can actually have a go at doing Git branches and kind of practice all of this. And that's probably the best way to learn it, but hopefully this gives you a bit of an overview of what Git branches do and why we use them. Another really useful thing is on GitHub, it's got this network graph view. So this is just a really nice way to actually visualize all your branches that you've made in a repository with someone else. So yeah, it's just a nice thing that's there that's useful to share because not everyone knows about it. Okay, and then moving on from Git branches, we've talked a little bit about different Git commands. So Joe's mentioned, the Git pull and Git push. So just explaining these in a little bit more detail here. So say you have your remote repository. So that would be GitHub or GitLab or whatever it is that you're using. So that's your remote space. And then you also have your local space. So that's what you're working on your laptop or your computer. So you need to git do git pull to essentially pull what's on GitHub down to your laptop or your local space to work on. So we do git pull, it's now in your workspace. You can now make edits and changes to any files. And then when you're done with that, you want to put it back onto GitHub. So we're going to do a few commands there. So we're going to do git add, and that just adds whatever what files we want to put onto GitHub. So any changes that we've made. So git add just puts them in this staging environment, this index space. And then we use git commit to then commit that to our local repository that's also just on our laptop or a computer. And when we do git commit, we also include a message as well. And I'm going to talk about that in a little bit more detail after this. And then once it's on your local repository, you can then use git push to push it onto GitHub or GitLab or whatever you're using. So these are really probably the 4 most common commands that you use when you're using Git. So it's useful just to explain them and how they work here. So yeah, just to talk in a little bit more detail about the git commit message then. So this is also can be written in shorthand with just a little -m. And a git commit message is essentially text that describes the changes that you've made in that commit. So those snapshots that Joe was talking about, the text that describes those changes. And the things that you might want to include when you're writing your git commit message are things like what change was made, why the change was necessary, and try and keep it clear, concise, and meaningful. And so this is just an example of a commit message for when we were making these slides and this presentation. So here I've done the -m, and then within the quotation marks, just adding the text for describing what that commit does. And this is how it looks on GitHub. If you want to add a little bit more detail than just this kind of short message that we've included, you can also include an additional -m after, and that just allows you to add a longer message of more of a description for your git commit. So here I've just added a bit of a description, kind of with a bit more detail on why I've done this commit and what's included in it. So yeah, so having good commit messages really helps you when you look back over your project, or if you're working with other people, you can quickly scan their git commit messages and see what they've done. So it's good practice to get into. This is an example of maybe things to try and avoid when you're writing git commit messages. Maybe it starts off with good intentions and then it kind of gets less and less informative. So that's something to try and avoid. Okay, and then here we've got a few more git commands that are useful. So I'm not going to go over this in detail, but this is a great resource for you to go back and have a look at after. There's a few which I will draw your attention to. So git stash and git stash pop. So these are really useful when working on different branches. So if you're on a branch and you start making edits and you realize you should have been on a different branch, using git stash is a really great way to kind of stash your changes, switch to the other branch, and then continue working there. So that's one I use quite a lot. And git add patch, I really like this for committing just chunks of a file rather than a whole file at a time. That's a really nice one to use as well. But yeah, there's lots more there that you can go back and have a look at. Okay, so we've talked a lot about Git commands like Git branching, Git commit, Git pull, but where do we actually type these commands? Where do you actually make Git work? So there's a few different options. So I like to use Git in the terminal. So this is a terminal on my Mac, and I think there's something similar for Windows users as well. And yeah, it's a very powerful way of using Git. So here, this is just an example of using the Git command. So first of all, start with Git status, and that just shows me what I've actually got in my repository, and then using Git add to add those files to this staging area. And you can see now that text has gone green, so that's in that staging environment. And then doing git commit and git push to put those onto GitHub. So that's an example of using Git in the terminal. We also have, you can use Git in graphical user interfaces or GUIs. So one I like to use a lot is RStudio. So do a lot of coding in R. And if you use RStudio projects, so you can see here the name of the project in RStudio up here. If you use projects, you also get to view this little Git tab in the window here. And that just allows you to use Git more interactively. So you can see what files you've been working on, and then you could click commit there, and that gives you this pop-out window where you can see the changes that you've made, you can see the files that have changed, and you can add a git commit message here. So that's a nice tool to use. Another one I like to use if I'm coding in anything but R, I like to use VS Code. So that's got a nice way of using GitHub, Git here as well. And you can see all the files that you've made changes to. The thing I really like about this is if you click, I don't know if you can see this little M here, which I think stands for modified. If you click on that, it gives you this really nice display of your changes. So the git diff, the difference between your old version and the changes you've made. And you can go through and just add chunks at a time if you want to just commit a chunk of your file. So yeah, I think that's a nice way of visualizing the changes that you've made. So I quite like using that. And then another one that's good to talk about is GitHub Desktop. So this isn't one I've used very much recently, but I think it's worth mentioning because it's developed by GitHub. And yeah, I'd say if you want to try using something other than the terminal, maybe have a look at a few of these, maybe have a look at GitHub Desktop as well. Yeah, so before we talk about GitHub in a little bit more detail, I thought it'd be good to kind of try and gauge how many people have used GitHub before as well. If you want to write that in the chat now before I hand over to Joe to talk a little bit more about what GitHub has to offer.
Excellent. Thanks very much, Amelia. So yeah, again, I think we can see a bit of a mixture of people that have engaged with GitHub. And obviously there are very similar tools, GitLab and Azure DevOps and all sorts. Bitbucket I saw was mentioned a wee bit earlier in the chat. So they're very, very similar. They're just essentially slight differences in how they're presented. So if you use another tool that isn't GitHub, you'll be familiar with some of the concepts that we're going to chat about. in a little bit more detail here. So yeah, we've spoken about Git and how we use Git to do our version control, and now we're going to chat a little bit more about GitHub and how we can engage with the different features that GitHub has to offer to help our collaborative working on code bases. So firstly, what is GitHub? So it's a cloud-based platform. We touched on this before for hosting our Git repositories, and the key thing there is it's hosting it. So GitHub is enabling us to work together on the code base. It's Git behind the scenes that's keeping track of how our files are changing. And the sort of features that GitHub offers, there are a few listed here. And these are really incredibly powerful features that enable us to work more effectively together on a code base that's being version controlled. And I'm going to chat a little bit more about these as we progress. But the first one is pull requests. And Amelia showed us that nice diagram of how we can use branches to progress through our tasks, and talked a little bit about merging those branches. We can use pull requests as part of that merging process to engage with other people in our team to talk about the work that we've done on a particular task, and we'll touch on that in a wee bit. Issues and projects are another really cool feature of GitHub and other tools, and these are essentially a way by which we can document the tasks or issues that we have with our code base. So we might have problems with our code base that we might want to fix, issues or bugs, or we might just have tasks that we want to progress with. So that could be adding a new feature to our code base or something like that. And we use issues to document those tasks, and we can combine issues with something called projects boards. And these are essentially a to-do list that everyone in the team can have a look at that enables us to monitor the progress of our tasks. We touched very briefly on actions before, and that's a feature that enables us to automate aspects of our building or testing or deploying of our code base or tools. And they can become really powerful as we start to think about continuous integration and continuous develop. So as we're maturing the tools that we develop, actions is a really powerful way that we can check, test, and then deploy whatever we're building. And then another feature that we'll chat a little bit more about is pages. So GitHub Pages, we touched a little bit on that earlier, but essentially it's a free place that we can host web material associated with our repository. So it can be tied to our repository, and it enables us to share, for example, documentation, or it could be websites for ourselves, or it could just be different outputs. And the presentation that we're looking at just now is an example of something that you can host on GitHub Pages. So we are hosting this presentation on the repository that Amelia and I were working on GitHub, and it's available just for anyone to go and have a look at. So a nice example of how we can host web-based materials, and we can do that because this presentation is designed to is presented in an HTML format, so a web-based file format, and that enables us to host it. So yeah, let's talk about these features in a little bit more detail. So firstly, pull requests. So it's an opportunity for us to share the changes that we've made on a code base with our team, and a really powerful, a really simple, but also really powerful way to enable collaborative working, and also just a moment for us to pause and reflect on the work that we've been doing. And on the right-hand side here is just a screenshot of what a pull request looks like in GitHub. And this was a piece of work that Amelia was doing, which was essentially creating those slides around Git branches and sort of helping us to understand the branching concept. And you can see that Amelia sort of just described quite nicely the work that was involved within that, just chatting essentially to me, describing the work that was done to help me understand, okay, well, what's been going on the code base. And once we've done that, we can use features like this files change tab, where we can go and look at those file changes in a lot more detail, line by line. We can see, okay, well, what's been added to the code base and what's changed. We also have a history of the commits, so we can see the commits that Amelia made in working on this task. So we've got a bit of a history there to see how it's developed. And a pull request, a branch doesn't need to be unique to an individual. So while Amelia did the work on creating that Git branch figure, I can come in and make changes too. And you can see that here where I've come in and just done a little bit of tidying up, in fact, for just this presentation, and suggested some changes to the Git images. And we can see that we've got that really rich history. We've got an opportunity for others to come in and make changes to the code base. We've got an opportunity to comment on the code base as well, ask questions, maybe say, oh, well, maybe we could have done this a little bit differently. We might want to include this before we progress. So it becomes a really simple way. It's just a way to comment on changes, but you can see everything together, and that's alongside the code base. And this will remain within the history of the code base as well. So we can go back and look at this pull request if we're interested in this feature is just about Git branches, but we might say, oh, well, actually, where did that come from? What was the purpose of adding that content in? We can go and look at that and see a really rich history of how that's changing. And then once we're happy, and we've had that discussion about the changes and we're happy with the changes that are being suggested and have been made, we can merge that in. And that's what you're seeing here towards the bottom. You've got this pull request has been successfully merged and closed, and that enables us to sort of move on to the next piece of work. And I mentioned issues and projects before. So issues is the way that we track tasks, and a project board is that opportunity. Is essentially a slightly more powerful to-do list. And we'll all be familiar with these. It's a Kanban board, and those come in all sorts of different tools and in all sorts of different formats. But on the right-hand side, we've just got a really simple version that Amelia and I used over the course of creating this presentation. And you can see we've got a to-do list. So these are the tasks that we still had to do. These are the tasks that were in progress, and these were the tasks that we'd done. And all of these are just essentially around just adding different content within the presentation. But we can click on these issues and we can get a lot more detail. What is the task that we want them to do? And then we can also have a conversation within those issues. You can see some of them do have a conversation associated with them. And we can really dive down into a particular task. And at the same time, at a high level, we can monitor changes, and we can say, oh, well, Joe, I need to go and pick up these last few changes as well as finish this one here. And you can see who's doing what and so on. And this becomes really, really important and powerful as your team grows and as the code base and the complexity of the code base develops. So simple tools that allow us to work collaboratively. And we've mentioned GitHub Actions. So these are really powerful tools that can be part of a continuous integration and continuous delivery workflow. And as I said before, they allow us to automate building and testing and publishing of our resources. And this becomes particularly important as our tools and code bases mature, and as we want to start sharing them with others. We might start versioning them and addressing bugs that different people are finding as they start to use our tools. So as our code bases mature and we're starting to publish them and have other people use them, these sort of things can be really powerful. And what's essentially happening is you've got a set of instructions which you will store as an action for your repository, and those instructions will be triggered and they will be ran on a virtual machine that GitHub offers. And it will go through and run through the different steps within your instructions and report back on how it got on. And a simple example of this is one we've got on the right-hand side. So this is a GitHub Actions workflow for a Python package that I use. So what we've got here is we've given it a relatively meaningful name. So it's just checking that the package that the Python package that we've built is going to build okay and not throw any errors. What's interesting here is this next stage. This is just telling us when it's going to be triggered. So we talked a little bit about branches there, and you saw at the top we had that main branch, which is our sort of main copy of our code base or tool. This is when this will be triggered. So it will be triggered when we want to make changes to our main branch. And in this case, it's going to run on a few different machines. So an Ubuntu machine, a Mac machine, and a Windows machine. And that's just to allow us to test that it's going to work on different operating systems. And we're going to use Python. We're going to install the requirements for our package, and then we're going to run some unit tests. And if this is going to be triggered every time changes are suggested to our main branch, it means that we can test the changes that are happening to the code base and just make sure that they're all passing before we then allow those changes to happen on the main branch. So a really powerful way that we can check code bases. And GitHub pages, these are essentially a way to host and share material in a relatively public way, although there are ways that you can manage the access to this. And just in this case, Amelia and I are both using GitHub pages to host websites. And that just gives an opportunity to chat a little bit about ourselves, but it's really, really powerful because this is free. So we can create a website, we can host it using GitHub pages, and that's a really brilliant way to sort of chat a little bit about ourselves and also continue to use version control. So I think, yeah, we're getting towards the end of the presentation now. I wanted to chat a little bit about Git security. So as we use version control tools, we just need to be conscious of what security considerations we need to bear in mind. So as we work with sensitive data, for example, how are we making sure that we're not going to accidentally put sensitive data within our code base that others may have access to. So here we're just going to chat a little bit about how we might go about doing that. And the first and the simplest way to do that is using what we call a git ignore file. And this is an example of that on the right-hand side. And it's just telling Git what to ignore. So in this case, we're saying don't look at any files within the data folder and don't look at any files within the outputs folder. And that's a really simple way to just avoid Git seeing our data files. We can override this, but as a simple protection, we can do that to avoid any outputs or data going into our repository. We can layer that up by just saying, actually, just ignore any CSV files or Excel files or any output files like PowerPoint or Word docs and so on. And that allows us to just very easily, if we accidentally drop an Excel file into our folder, Git's not going to start looking at that folder and pushing it up to Git and GitHub, sorry, where other people may have access to it. And that's not a good way to manage access to data. We can also use tools to help us think about not putting sensitive content in. So firstly, we shouldn't do it. So try not to put passwords and API keys and individual people's details within the code. There's no need to do that. But there are tools that can help you if you have done that to go back and remove them. And there's also tools like pre-commit, which can add simple checks to make sure that those aren't appearing in your code. And we'll chat a little bit about that in a second. And we can also manage who's accessing our repository. So not only accessing, but also able to edit it. So we've got fine levels of control that enables us to use powerful tools like Git and GitHub in a secure way that acknowledges the risks associated with the work that we might be doing. So Git pre-commit, I mentioned that just before. This is essentially a similar thing to GitHub Actions. It's another part of our continuous integration and automation of checking. And this one is this will be triggered when we commit something. So when we try to change something, we can use a tool called pre-commit, which will, as you can see on the right-hand side here, just run a series of checks after we've tried to commit some changes. And those checks can be all sorts of different things. I'd really recommend going and having a wee look, but you'll see in a second that in this case, we're just running some simple checks around formatting, but also we've added just a wee security related one, which is going to detect any private keys. So if you've accidentally put a Google Earth API key in there or something like that, this will check that and it will fail that check and ask you to go and have a look at the code base. So we can add simple features like that that can monitor our code base as we're changing it. And we can also, so we've got really simple ones here, but we can also add things that might format our R code or our Python code as part of this process. So things that can help us create standard high quality code bases as we work. And I'll just finish there with there's loads of resources out there that can help us when we're working with Git and GitHub. I use them every day. I've used Git and GitHub for years and years, but I still go and have a look at these resources and double check the commands because I apparently can't hold more than 3 commands in my mind at any one time. So I find these resources really, really useful. There's many, many more out there, but do go and have a look at these. We mentioned there's a wee game here around Git branches to help us wrap our head around some of these concepts. Some Git concepts can be really tricky to just to figure out, and it just takes a little bit of time to play around with these tools to understand why they're valuable. But yeah, loads of interesting guidance here, and we'll be sharing the slides so you can go and have a wee look at these, and then hopefully they'll be useful as you start to use Git. But I will finish there, and we'll just see if we've got any questions.
Hello, everyone. Thank you so much, Joe and Amelia. We could just start with some of the questions. I think if we just start at the bottom and go up. I don't know whether that's a good way to do it, but Rocco has asked about, is just the confidence to get started, and I get this. How can you give a bit of advice on how to get started when you know that other people in in the resource are more experienced? Joseph, do you think that?
Yeah, I can jump in on this one. So yeah, this is a brilliant question. So Git, as with many open source tools, can be a bit intimidating at the start. Particularly you've got all these words, concepts, repositories, and committing and branching. We like to give things strange names that people don't understand. But yeah, the amazing thing about Git and GitHub is that they're free, and you can install them and just have a play without spending any money. And you can also do it on just sort of pet projects. So you don't need to necessarily integrate these tools into your ways of working where you might have a lot of pressure to deliver something. You could just try it out on a few examples like some R code or Python code that you might be playing around with, or any code. So my advice would be don't worry too much, just get started. Things will break. Things break all the time. I broke. In fact, I probably got to, after this call, go and fix some Git stuff that I've broken. Doesn't matter how long you've used it, there'll be things that you don't know and things that you struggle with. So I wouldn't worry too much. I'd just get started and chuck any old code into a repository on GitHub, and just have a play and start looking at some of these features. And as you progress, start to think about, okay, well, how can I integrate this into how I work? And the more that you start to use these tools, the more confident you'll become. But yeah, don't worry too much about being worried at the start. These tools are very intimidating, and we've all been in that position, and I continue to be in that position where I don't have a clue what's going on, and thankfully the internet is there to help us out.
Oh, thanks so much. So I've reordered so that we've got the most popular questions at the top now. Can you explain the icons in GitHub for us, please? Amelia, is that one for you?
The icons, I'm not quite sure what the icons are.
Okay, we can come back to that. Perhaps Claire, you could give us a bit of clarification there. So Alex is asking, you used some examples earlier on how you've both used Git to track version control in this presentation. Can you talk about how to manage collaboration on a large scale with multiple contributors?
I think it's quite similar to how we've used it with just two of us, like using multiple branches, using pull requests and code review. Just means that more people are coming on and commenting on your pull requests. So yeah, I think that framework's there for working with any amount of people. I mean, sometimes it's even just you and like just one person on the code base, and you can still do pull requests and code reviews on your own code, or you can just have, lots of people. So yeah, if you've got anything to add on that, Joe.
No, nothing. Yeah, I think it's exactly that. It's just exactly what we've covered today. They are being used in the development of incredibly important tools like software that we engage with on a daily basis, Zoom and Teams and Google. All these things will use version control in the background. But the amazing thing is that they're not doing anything beyond what we've covered today. It's just taking these simple building blocks and building them into a really complex tool where you've got lots of different teams working on lots of different aspects of the code base. They'll just be using branches and pull requests and code review and GitHub Actions for testing. They'll be using all of those in combination with the different aspects of the code base. So simple things can be built into really complex procedures.
Oh, thank you. So here's another question about building confidence, are there any commonly but easily avoidable mistakes you see with people starting out on Git and GitHub?
I can think of one when you're working with other people, forgetting to do git pull, and someone's made changes on, and it's all changed on GitHub, and then you start making changes to your local version, but actually you've forgotten to do git pull before you start making those changes, and then that's just a bit of a nightmare to resolve all the sort of like the conflicts that come with that. It is possible, but it certainly makes your life a lot easier if you remember to do git pull and then work on your code. So that's the one I would say.
Yeah, so Adam has just asked about how you best resolve Git conflicts, but I think you've possibly covered that now. So Vivian has got concerns about security and GDPR. So you covered that in the presentation.
Yeah, just to maybe briefly touch on that, it's really important, obviously, with everything that we're doing, to be conscious of what we're doing and the data that we're working with. What Git is working with ideally is our coding files, and ideally with our coding, we shouldn't, as much as possible, have anything sensitive within that. So data is a whole other story, and we talked a little bit about using git ignore and other features to avoid us putting data onto our tools like GitHub. But yeah, within our code bases, algorithmically, we also need to think about the sensitive aspects of that. And that's where it comes into controlling access. So not everything that we can do can be public for everyone to view. There's lots of tools within GitHub that enable us to manage the access of our code. And then we can use tools like git ignore and free commit and actions to make sure that we're not putting data that shouldn't be on GitHub. And there are also, if you make mistakes, which they do happen, and I've done it plenty of times, it's embarrassing to admit, but I've put passwords in coding files in the past and then frantically wondered how on earth I can remove them. There are tools out there that can help you with that process. So you will make loads of mistakes with Git, and it's just about getting help from online. But yeah, GDPR is really important, and there are lots of tools within GitHub that enable us to work effectively on even the most sensitive of analyses. And yeah, as Byron's saying in the chat, there are alternatives to these as well, which can enable you to work on more sensitive things where you might not want to move any of your code off your premises, for example, and GitLab is a good option for that.
So here's a question about the Forte software that I think maybe you mentioned, Amelia. Can you give us a bit more detail?
I mentioned using RStudio, VS Code, and GitHub Desktop. So they're just like graphical user interfaces. Like RStudio and VS Code are used for writing your R and your other code. GitHub Desktop, I've not really used that one much for quite a few years. But yeah, it's probably worth having a look at if it's something, if you're kind of new to Git and a bit intimidated by the command line. It's quite similar to the other ones, I think. Yeah.
Thank you. So someone else is asking about why use GitHub over other similar resources, and also, do you have any suggestions for open source projects? I know that that Byron put a little comment in the chat, but have you got any other favorites? Are there any contenders in your preference box?
I mean, I've mostly just used GitHub and a bit of GitLab, but yeah.
Yeah, so I barely use GitHub at all, actually, in my current organization. So we use Azure DevOps. But yeah, there's all sorts of tools out there. So the common ones, Azure DevOps, GitHub, GitLab, Bitbucket, those ones that you'll be familiar with. The great thing about them is that they're very, very similar. So jumping between one to another, or choosing which one, is just depends on how you work and how your organization works. But you shouldn't worry too much about not using GitHub and maybe using something else. That's something that I was a little worried about when I came to join University of Glasgow, but Azure DevOps is very, very similar to GitHub. So yeah, they all offer very similar features, and it's just about what works for you and your organization.
someone here is asking, can you easily create a branch from a local folder?
Yes, so using those git branch commands to make branches, or using the graphical user interfaces to kind of to visualize what branches you've made and what branch you're on. Yeah, so there's a load of git commands. So git branch, git checkout, they're the main ones that you use when using git branches.
Okay, I think we're running out of time, but we'll just go back to Claire's question, because she asked about the icons, and she said she's only seen GitHub in the browser, so the icons question was relating to that. We can come back to that. We can, you know, you've given a lot of resources in this webinar, so hopefully there's an answer there. Okay, so here's the last question is from Ron, and he said he's a lone developer. So can we suggest ways to get opportunities to practice working collaboratively? Any ideas, suggestions?
This is a good one, and it can be really tricky to learn these tools when you're not working within a team. The thing I'd say is there are lots of open source code bases out there on GitHub. Go and have a wee look. If there's any packages that you're using as part of your work, you can actively contribute to those. It doesn't need to be massive. Like, it could just be a wee edit to a README, adding some helpful instructions, or it could be creating a new feature. You can engage with the open source community beyond your organization, and that's one way to do it. The other thing is just playing around with these tools yourself, creating your own branches. Just sort of imagine you're working with other people. And another example is what we've done here. So Amelia and I have sort of created working collaboratively on a code base out of this presentation, because we didn't need to. I mean, you can create a presentation in a single file really easily, but we wanted to sort of demonstrate how you might go about it in a collaborative way using open source tools. So you can just sort of create it out of a particular task that you have in mind, and maybe engage with others in your organization or others out with it to work on this. And here's a nice example of working cross-organization on something that's not sensitive. So we don't need to worry about working in the open, but we can use all these different tools as a sort of demonstration of how they might work in practice.
Well, I think we'll need to wrap up there. We've actually run over time. There's a lot more questions that we will answer and pass round our fantastic audience. Thank you so much, Joe and Amelia, for such a lovely collaborative presentation, you know, taking us through what Git and GitHub means, and helping us all get a start in the right direction, I hope. Thank you very much. Thanks to our audience, and have a good afternoon, and I hope you all get some sunshine. Thank you so much, everyone.